Hello friends, welcome you all to the next lecture of the JCE Connect series of lectures. In today's class, we will be discussing about moment and its applications. So, I will like here to mention that the concept of moment is there in 2 to 3 modules part by part. Okay, so we have decided to teach all those concepts together, and hence I have titled this video as moment and its applications. So the contents for the today's video lectures will be as follows. Firstly, we'll again briefly go through the definition of moment. We'll discuss the type of moments. Then we'll understand the non-concurrent coplanar force system. Based on this, we have the principle of Malignant theorems, and then in the further lectures we'll be solving the problems. So let's start with today's lecture. Firstly, let me define moment once again for you. Moment of a force. The turning effect produced by a force on a body is known as the moment of the force. The turning effect or the rotating effect which a force produces when it is applied on a body, we term it as a moment of a force. The magnitude of the moment is given by the product of magnitude of the force and the perpendicular distance between the line of action of the force and the point of rotation, okay, about which the rotation takes place, about which point the rotation takes place, and the magnitude. Okay, so when we talk about moments, there are generally two types of moments. One is a clockwise moment, which we take as positive. Second one is an anti-clockwise moment when we consider it as a negative. So to make the definition of moment more clear, I have added some animations. Now let us consider this horizontal element in red color as a beam. Let us say that its length is L. Okay, so consider the horizontal element. Now I am applying a force at its right edge from the top. Okay, what I am doing, I am applying a force at its right edge. I have not defined any magnitude. Let us consider the magnitude of the force to be F. Okay, so now if I consider the point O, which is at the left end of the beam, as the moment center, means that is the point about which I am calculating the moment. Okay, then how will the beam rotate? The beam will rotate in clockwise direction with this force. Okay, now again see the concept. When the force is applied at the right end from the top, how is the rotation of the beam? The beam is rotating in the clockwise direction. So force magnitude क्या बोला हमने? F. Let the length of the beam be L. Then as per the definition of moment, the magnitude of moment at point O, okay, now which is your point O? This is your point O. Okay, about this point, if you want to calculate the magnitude of moment, it will be the magnitude of the force which we have taken as F and the perpendicular distance. Okay, here in this case the perpendicular distance from point O to the point of application of the force is nothing but the length of the beam which we have taken as L. So moment in this case will be what? F into L, and as the effect is clockwise, okay, as the effect is clockwise, see the effect, it is clockwise, so it will be with a positive sign. Now if the force has a value say 10 units or say 10 Newton, and if the beam is of the length 5 meters, then what will be the moment? Magnitude of the force 10 multiplied by length of the beam 5. 10 5s are 50. And how is the beam rotating? The beam is rotating in clockwise direction. okay, or the beam is turning in clockwise direction, hence it will be plus 50. So with this illustration I have tried to once again elaborate the definition of moment. Now further I'll take the same beam, okay, I'll take the same beam. Now in this case I am applying the force not from the top but from the bottom, okay. In this case what I am doing, I am applying the force from the bottom. Again I'll consider a point O which is at the left end as the moment center, okay, or this is the point about which we want the moment to be calculated. The length of the beam is L and magnitude of the force is F. So now what will happen in this case? Now in this case the beam will rotate in anti-clockwise direction, okay. The beam here is rotating in anti-clockwise direction when the force was applied from the bottom, okay. Now see these basic things. You can hold a scale in your hand, take a pencil as a force, apply the pencil at the tip from the top, okay. How the scale will move? It will go downwards or it will go in the clockwise direction. If you apply the same force from the bottom, what will happen? Guys, what will happen when if you apply the force from the bottom? It will move in anti-clockwise direction, okay. So this is what I wanted to elaborate the definition once again for the moment. So moment is the turning effect or the rotating effect produced by the force. Now the most important things to be understood here are the point about which we are calculating the moment is known as moment center, okay, and the lever arm or the rotating action is produced about which length, the perpendicular length, is termed as the moment arm or lever arm. Now in this case the length of the beam itself was the moment arm, okay. Now if here again the value of the force was 10 units and the length of the beam was 5 units, what would happen here? Again the magnitude of the moment will be force into the distance, that is 10 into 550, but in this case, in the second case where the force is acting from the bottom, the rotation caused is in anti-clockwise direction, hence it will be with the minus sign. Therefore our answer for the second case will be minus 50. Just for better explanation I have taken this small example. Hope this animation has helped you in understanding the concept of moment in a better way. So let's continue our discussion and study the coplanar non-concurrent force system. So what is a coplanar non-concurrent force system? If two or more forces are acting in a single plane but not passing through the same single point, such a force system is known as coplanar non-concurrent force system, okay. So here we have two forces which are in the same plane but they are not passing through a single common point, okay. They are not passing through the single common point, hence those are coplanar non-concurrent force system. In coplanar non-concurrent force system, we can calculate the magnitude and direction and position of the resultant, okay, as follows. Magnitude is defined by the same relationship which we have used in module 1 and 2, r is equal to square root of summation fx square plus summation fy square. Theta is equal to tan inverse of summation fy upon summation fx. Then the next concept comes is the position of the resultant, okay. For the previous examples, as they were concurrent, theta used to define the position of the resultant also, but here as it is a non-concurrent force system, along with theta we need to locate the resultant, okay. We need to locate the resultant. So when we want to locate the resultant, the following relationships we have to use. Firstly, R into D is equal to algebraic sum of moments of number of forces about the point. What is R? R is the resultant. What is D from the figure? It is the perpendicular distance. Okay. Now, how will we get the resultant? Resultant is action of number of forces. Okay. So, R into D is the moment of the resultant. So, what will be the moment of the resultant? Nothing but moment of number of forces which are involved in the system. Now, this definition which I am telling you now will be much more clear when we go through the Varignon's theorem. So, here if you want to locate the distance, okay, from a particular point, the perpendicular distance of the resultant, we have to use the relationship summation of moments upon R. Summation of moments means moments caused by individual forces, because a number of individual forces give rise to a resultant. So, when we want to find the location of that resultant, we are using the formula summation of moment upon R. Similarly, if you want to find x-intercept and y-intercept, we get that by using the formula summation m upon summation fx, summation m upon summation fy. So, don't worry much about this. When we solve one or two examples, this concept will be clear. But now, let us focus on this R into D is equal to algebraic sum of moments of number of forces about that point. This concept will be proved by Varignon's theorem. So, let us start with Varignon's theorem of moments. I like to inform you all that this is one of the most favorite questions of the examiners. If there was a written internal, this question was but obvious for your internals. In the maximum final exam papers, we find this question. This is a straightforward derivation which is asked for 8 to 12 marks. Okay. So, I will try to explain this derivation properly. If you get any doubts, you are free to revert back to me. So, the theorem starts with its statement. The statement has to be written as it is. The statement says, the algebraic sum of moments of individual forces of a force system about a point is equal to the moment of their resultant about the same point. What does this mean? If there are a number of forces acting, those all forces will give one resultant. Okay. So, if we find the moment of the resultant, okay, that should be equal to the summation of moment of the individual forces, because how we get the resultant? Resultant is a single effect of all the forces combined together. So, what moment the resultant produces, the same moment we will get when we add the moment of a number of individual forces which are acting. Okay. The figure now which I will be showing you all with animations will make this definition more clear. So, consider a point at which two forces P1 and P2 are acting. So, let O be the point where two forces, one is P1, another forces P2 are acting. Okay. Now, next let R be the resultant of these two forces. So, R is the resultant of these two forces. So, consider a point B as moment center. Now, the point B which is shown here by a star mark. Okay. About this point I want to find the moment. Okay. About this point I want to find the moment. Now, see, this point is out of the three forces. Okay. The forces are not going through that point, or they are not meeting at that point. About the point B, I want to find the moment of the forces. So, let D1, D2 and D be the moment arms for R, P1 and P2 respectively from the moment center B. So, what is D1? D1 is the perpendicular distance of the force P1 from the moment center. What is D2? It is the perpendicular distance of the force P2 from the moment center. Similarly, the resultant is located at a perpendicular distance of d. So now, if in this scenario, as per Varignan's theorem, okay, as per Varignan's theorem, R into d is equal to P1 into d1 plus P2 into d2. Okay, so how to elaborate the statement? What is R into d? It is the resultant moment caused because of the resultant. R is the resultant and small d is what? The perpendicular distance from which point? Moment center, which is B in this case. Now, this should be equal to P1 d1 plus P2 d2. Now, what is P1 d1? It is the moment caused by the force P1 about which point? About same point B. And what is P2 d2? P2 d2 is the moment caused because of the force P2 about the same point B. So, when we add these both, that is P1 d1 plus P2 d2, it will be equal to the moment caused by the resultant, which is R into d. Okay. So, if you have one more force or if you have two more forces also, the statement remains the same. So, this is what is the statement of Varignan's theorem. Now, let us prove this. Okay. Let us prove the statement. So, every theorem has a proof. We will try and understand the proof. So, I have taken that figure here, the first figure on the left hand side. This is my point B. These are the distances d1, d2 and d with respect to P1, P2 and R. Okay. So, P1, P2 are the two forces, R is the resultant. The distances of these three elements, that is P1, P2 and R, from point B, okay, from point B are d1, d2 and d respectively. Then in the second figure, what we have done here is, let's understand. Join AB and consider it as the y-axis and draw the x-axis at right angle to it at A. So, what I am doing is, from point A, I have joined AB, then this itself, AB itself, okay, I am considering AB means our O point. O point I am taking it here as A. You can say it OB also, not an issue. This AB itself I am taking as y-axis. So, your x-axis will be perpendicular to it. So, first draw x and y-axis. Then keep our forces P1 and P2 as it is. Now, don't worry, this can be P1, this can be P2, this can be P2 or this can be P1. That doesn't affect here. Okay, as this diagram is there, concentrate on this figure itself. These two figures will be important. The previous animation was just to show the statement. Okay, so don't say that, sir, in that you have marked P1 as this. Don't be too silly sometimes. Okay, use your brain. Here just we are discussing. So, what is P1 and what is P2 doesn't matter. What matters is proving the statement of the theorem. So, follow these two figures. Okay. Then let theta be the angle made by R with which axis? X-axis. Okay. Let theta be the angle made by R with the x-axis. So, here we are able to see that angle. Okay. Here we are able to see that angle theta, which is made by the resultant R with the x-axis. So, similarly, okay, similarly we will get this angle theta here with the y-axis. Both the angles are the same. Okay. So, angle theta is the angle made by the resultant with respect to the axis y and x as shown in the figure. Now, here the points B and B1 represent the perpendicular which is dropped, okay, on the resultant from y-axis. Then we know that RD, that is R into D, is equal to R into AB cos theta. So here what we are doing is, from this triangle ABB dash, we are finding the value of D. Okay, what we are doing from the triangle ABB dash, we are trying to find the value of D. So what is D? D is the perpendicular. So what will be AB? AB will be the hypotenuse. And what is AB1? AB1 will be the base. So when we want to find D, we can use the cos principle. That is cos theta. If we use, we will get cos theta as, what will get cos theta as? AB upon D. Therefore D will be equal to AB cos theta. So draw this triangle properly. This theta is there. You can easily apply the cos principle and get the value of D. We get D as AB cos theta. Okay, it is here. Then further, just will interchange the terms. In place of AB will take R, as it is multiplication, it won't affect the result. So what will be RD? RD will be AB into R cos theta. But what is R cos theta? It is the x component of the resultant. Therefore RD is equal to AB into Rx. So if you concentrate a bit and try to understand, this theorem is very much easy. Okay, so basically we are dealing with the triangle ABB dash, sorry ABB1, wherein with respect to the angle theta, we use the cos principle and get the value of D, and we substitute that in place of RD. Okay, R is the same, whereas the value of D is AB cos theta. Next what we do? We just interchange the terms. Okay, once we interchange the terms, we get a term R cos theta. What will be R cos theta? It is nothing but the x component of the resultant. So we can write RD as AB into Rx. For your reference, in the next view also I have kept the figures. Now when Rx is the component of R in x direction, similarly now if we want to find components of the force P1 and P2 in x directions with respect to the perpendicular distances D1 and D2, now you can develop similar triangles. Okay, so first triangle what we developed was ABB1. It was only with respect to the resultant. Now forget resultant. Take the force P1. Okay, develop such triangle. Take the force P2. Develop such triangle. So instead of doing all this, as it is similar, directly we can write P1 into D1 is equal to AB into P1x. And similarly P2 into D2 is equal to AB into P2x. Okay, as already we have proved in the previous slide with respect to the resultant, that P into D is equal to AB into Px. Okay, so similarly directly we can use that principle and apply it for the two forces. Okay, compare this. Equation 2 and 3, they have been generated by using the equation 1. Okay, so P1 into D1 is equal to AB into P1x. What is P1x? X component of force P1. And what is P2x? X component of the force P2. Therefore we get the equations 2 and 3. Adding equations 2 and 3, we get P1 D1 plus P2 D2 is equal to, AB is common in both, P1x plus P2x. Okay, so now this becomes very important statement. Okay, where we have added equations 2 and 3. Then in the next step, P1 into D1 plus P2 into D2 is equal to AB. Now what is P1x plus P2x? Summation of forces along x direction. that is nothing but Rx. Okay, summation of forces along x direction, P1 ka x component, P2 ka x component. When we are adding them, it is nothing but what it is? It is Rx. So this is your equation 4. Since the sum of x components of individual forces is equal to the x component of the resultant from equation 1 and 4. Okay. Now what we will compare? We will compare equation 1 and 4, because what is happening here in the equation 1 and 4? It is dealing with the resultant. Okay. So when we compare equation 1 and 4, what we will get? Rd is equal to P1 d1 plus P2 d2. So as simple as that. We see that in equation 1 and equation 4, right hand sides are the same. Therefore, we can say the left hand sides also have to be the same, which is Rd is equal to P1 d1 plus P2 d2. This is nothing but the statement of our Varignan's theorem. The moment produced by the resultant is equal to the sum of the moments produced by the individual forces about the same point. So Varignan's theorem is very easy. First will be the statement of the theorem. Okay. Then we will understand the statement and decide what we have to prove. Then starts the proof. So in the proof, we consider the triangle A, B, B dash, and from that we get our equation 1, which is the most important equation. Then further we apply that equation 1 on similar basis. We find equation 2 and 3 with respect to the forces. Then further solving equation, adding equation 2 and 3, we get equation 4. Comparing equation 1 and 4, we get the required output, that is the proof of Varignan's theorem. So go through the video carefully. I will send a PDF notes also. Don't hurry up yourself. Understand it, and then again if you find any difficulty anywhere, okay, you can come back. So hopefully this lecture will be a fruitful one, and further in the further lectures we will be solving the examples. Thank you.